The difference between these two problems is the negative exponent. I would interchange the one on the right to say the third root of 27, and the third root of 27 is 3. Well, the one on the left, I cannot do that same thing. I cannot just take a negative root. So what I'm going to have to do on the one on the left is make it a fraction and move this down here. So I have 1 over 27 to the 1/3 power. At that point, I can turn it into a root and the third root. And my final answer here is 1/3. We're going to look at use property of exponents to simplify this. And the basic property that says a raised to the b power equals a to the c power if and only if b equals c. So if I have common bases, then I can drop the base and the exponents equal each other. So let's look at this piece here. I have 2 and 8. Those are not the same. Can I break down the bigger one? So if I say 2 to the what power gives me 8, and 2 to the 3rd power gives me 8. But I still have this x plus 6. And on this side, I have 2x plus 4. Now the bases are alike, so I can drop them, and I can state that the exponents equal each other. Now I'm just going to solve. I'm going to distribute the 3. I'm going to move the x over. So I have 4 equals 2x plus 18. I will subtract 18 to both sides. So I have 2x equals negative 14. Divide both sides by 2. And x equals negative 7. And there's my final answer. I can plug in negative 7 in both places here. And if I was to simplify that, on the left-hand side, I would get 2 to the negative 3rd equals 8 to the negative 1. And if I simplified that to fractions, I would get 1 over 2 to the 3rd equals 1 over 8. Therefore, 1/8 equals 1/8. And I would know that this answer is correct. Let's take a look at one more. We talk about never having exponents as being negative, but in this case, it's going to be pretty hard for me to break down 81 into a fraction. So here's what I have right here. On the bottom is x, or 3 to the 1st power. If I move it up, I get 3 to the negative 1st power and an x. Now, I can break 81 down